The title of this presentation is The Bones of High Availability, if you couldn't already tell from my handy-dandy title screen. My name is Shaun Thomas. I wrote the PostgreSQL high availability cookbook thing that they published, I think, last year. And I apologize in advance, mostly for myself, but this presentation is going to be an endless barrage of puns and colloquialisms, and it's all horrible. And I couldn't help myself. I just couldn't resist I did this in all my previous presentations too. The slides are all titled in puns. It's ridiculous. And I know some of you that's physically painful, so just, roll with it. I apologize. It's just something you're going to have to put up with. And I work for a company who does a lot of financial stuff, so we have numerous databases, big databases. Our largest one is 27 terabytes right now, and it grows by 2 terabytes a week. And it's all in Postgres, so in case you're wondering. Obviously, since I'm in head of charge of everything, I push Postgres as hard as I can, and they listen to me for some strange reason. So what is high availability? I actually saw the slide in the, in the lightning talks yesterday, and I had to steal it because really, what is high availability? It's spending all of your money on a lot of extra servers you don't really want, but you're buying them anyway. Because in the long run, that's what high availability is. You sit down and you say, what is the cost of my system being down versus the cost of buying extra servers? And this goes for cloud systems too. Because if you're in a cloud system, you want to be in multiple availability zones, or you want to have multiple cloud structures in different regions. However you want to do it, you've got to spread it around, and that's you got to pay for that. And a little more formally, I've got a few bullet points on it. That's actually what it is. It can get expensive. You're sitting there trying to decide what you want to put in all of your data centers, if you have multiple data centers, which we'll get to in a minute. But that's what high availability is. It's this, in a nutshell. And this presentation is going to go over starting from start to finish, starting off with one server, and eventually I think my last slide has 7. And I'll try to justify each step. And then as your company organizations get larger and you decide how much money you can or want to spend, you can decide which bit of infrastructure you want to kind of go with. And usually it also depends on how paranoid you are. Like, how much do you think your stuff's going to fail and die? And that's really what it boils down to. How likely you are and how much you need to stay up and how paranoid you are that's going to crash on you. So what are bones? Fun fact, you may not have known this. You, in fact, contain a spooky skeleton. And one of the things we're going to be doing during this, and like I mentioned, we're going to be building a skeleton for Postgres. And by skeleton, I mean server structure. The architecture, the foundation that builds everything your database runs on. This is what we're going to be doing here. And there's going to be a lot of slides like this, so I apologize again. I couldn't resist the temptation. I got a lot of this off the internet. Thank you for stock footage. Like, you know what I mean now? One is the loneliest number. Seriously, that's the name of my slide here. So we're starting with one node now. You've probably seen one of these. In fact, you probably have made one on your own. And you're like, I got my Postgres database. It's up and running. And I got my backups here. And then my eggs in one basket. Doesn't matter. I've got my system running. This is where my database is. And the reason you run into stuff like this is because you've got a company. And, honestly, they're not database administrators. They're some devs and maybe some management. They set up a database. And they're like, OK, we need our database to run on a server. And then they forget about it. So you get this running, and it's kind of sitting around, gathering dust, running your database, and they don't think about it until it dies or crashes or something. So I really couldn't resist this one either, because now why is this server sad? Because he's all by himself, right? So here's what it boils down to in this situation. You put everything on here, your backups too, because you're just backing up your server as a SQL dump, right? And you're just putting them in a directory somewhere on the server. And you've got a backup. If the server crashes or is corrupt, you just, on the same machine, you make a new instance and you restore it there and you're fine, right? No problem. Generally, that is a problem, and I'll tell you why. One of the first companies I started to work for exclusively with Postgres in 2005, we had a server like this. It was an old FreeBSD system. Now, it was like 4.2 or something, and at the time, FreeBSD was on 5 or 6, so it was super old. It only had 40 gigabytes of space, and it was all RAID 5. So if anyone here tells you that RAID is a backup, they're lying to you. Slap them and then push them down a flight of stairs or something, because they're actively trying to make you destroy your cluster or your databases and stuff. RAID is not a backup. It's a high availability solution for your data. It's a way to keep your data available. If you lose a disk, you can put another disk in there and you still got it. But if there's something wrong with the server itself or your data gets corrupt, you have no backup. It's only there to make sure your data is available more often than it could be. So in this particular situation, we had our server up and it was running, it was great. I was hired that week and I come into the situation going, oh, what's your Postgres setup look like? It was 100% utilized. And by utilized, I mean disk space-wise. Back in those bad old days in 2005, we had a setting called max FSM pages. That setting has since been deprecated, but what it used to do is you would set it to the number of rows that would be kind of tracked after you vacuum. Now that's all done automatically. But at the time, you actually had to set it, and the default was only 200,000. Now, after I was done playing with their system, the setting they should have had was about 2.5 million. So, I mean, this is what boils down to, again, these people don't administer Postgres systems. They don't understand the implications of MVCC and what happens if vacuum's not set up properly. So their database had bloated to fill up the entire disk, and it was literally like a week away from filling the disk completely, and they had no extra machines to put this on somewhere else so we could actually not have the system go down. This was their primary database for all of their websites. If this server died, they could go out of business. So I'm not joking when I say I see a situation sometimes, and it's not an isolated case. It's easy to do, and it's easy to do wrong. And this is why I say your high availability is your structure, your foundation that you base everything else on. And if you get it on one server, you have no high availability, you have nothing. So how I fixed it is it just so happened that back then vacuum full was the only way to clean up tables. And so I started off with the smallest table because that was all I had space for. And I kept vacuum fulling everything all the way down the line until I got to the biggest table. When everything was said and done, 15 gigs. So 40 gigs to 15 gigs was this database after it had gotten to its ideal size. And eventually it got to 80 gigs on another server when we finally migrated stuff over, and that was legitimate data. But at the time, their database had almost tripled in size from bloat. And because it was on its own server, the one single point of failure, they had no high availability, they had no alternative. So I'm going to go ahead and add a server, but it's not the one you think. Remember how I said the backups were all on the same server? Well, you got to put them somewhere else. Now, to be fair, this is not a Postgres server. If you work with Agile, you've probably heard the phrase pig versus a chicken. So in this particular situation, Postgres is the pig. It's dedicated to the job that it's doing. And the backup server is the chicken. It's involved, right? It can make things that you might use with this particular situation that you're running backups on. Usually this is a shared service, like you have one backup server that multiple things will send data to, and hopefully that eventually gets sent to tape or some other offsite location. But this is what your cluster should look like at minimum. There should be nothing else. You can't really go before this. Like the one server is not even a thing you should have. But the problem is backups need to be restored. And usually what I recommend for this, if you have a minimal infrastructure, you can't afford to have a stack of 20 servers that are just kind of sitting around doing nothing. Have one spare server. It's kind of like having a RAID. You've got a spare drive that you can just kind of shove in where you need to. Have a floating server you can use for web services or database services. If you have a machine die, you need to kind of slot another machine in there to replace it. That's where you would restore the backup if your server dies. That's not on the screen because it's a shared service you can kind of use wherever. So I like to talk about Abe. And what I mean by Abe is not our venerable ex-president, but I say always back up elsewhere. And that's in this case, the literal interpretation of the slide I just showed you a couple minutes ago. Your backups do not exist if they're on the same machine the backups are happening on. Now, I don't care what you do afterwards. Like, you can take the backups locally as long as you send them somewhere else afterwards. And that's not how all my systems work, because they're all binary backups, and that's really hard to do outside of the machine that the binary data lives on. But right after the backup finishes, I send it off to some server over our 10 gig Ethernet, for it to be backed up on tape and then sent off to some archive in a vault somewhere. But no matter what you do, these are your three elements. Backups must exist, assume a server can die, go back to one. So I'm going to add another server to this stack. There's actually a really nice talk by Brian, I think, at 5 o'clock for Pacemaker. But there's a lot of different ways to glue these servers together, right? You can use Postgres replication. You can use DRBD. You can use etcd and HA proxy. You can use Sloaney. There's a trillion solutions to have your replica be the same thing as your other server. Usually what I recommend in this case is you have the same hardware. Why the same hardware? Well, if the main server goes down, you don't want the second one to immediately crash under the pressure and load of everything else that's hitting it. It's all about staying online. And again, like all the technologies I've mentioned, those are all some of them. Like there's a lot of other stuff out there, but these are the main ones that are kind of been in practice that I've seen kind of through the years. And actually, the etcd HA proxy, I mentioned that one specifically because there was a really good post on that had made its way to Planet Postgres. That's where everything kind of gets aggregated for Postgres-related articles. And they had mentioned about how they used etcd and HA proxy to roll their own semi-cloud for keeping Postgres highly available. And they talk a lot about how they kind of came up with that structure and how they kind of implemented it. So it really comes in handy to see a lot of this stuff. And there's at least 3 or 4 pacemaker and DRBD examples. Like I did one myself in 2012, and those slides are also online. So, and then the other one that's happening here at 5, and I think the room over there, Suite 4. So there's plenty of education out there in order to build this kind of system. But always make sure you have some kind of physical mirror clone of your other server, because again, this is where your paranoia pays off as a Postgres admin. If your server dies, you've got a backup that's online right now. Your downtime has suddenly been reduced from the time it takes to restore backup to however long it takes to fail over to the secondary node. And this, in my opinion, is the minimum of a highly available system. You need at least 2. However you decide to implement them is up to you, but you need at least 2. So now we're going to start spending some money now. Now we're going to start talking about multiple data centers. Not everyone can afford this, and I don't blame them, because when you're starting to pay for having servers in multiple locations, that's when you know you're hitting the big time. The first thing I would move is the backups. Offsite backups are a godsend, because if something happens to your data center or the backups are somehow unavailable or you can't restore them, you need to have them somewhere else where you can get to them if you need to. A lot of companies, like I said, since they're a shared backup resource, will already have something like this in place. If you don't, make one. Like, it's a really super handy thing to have around. And again, it's part of your foundation. If you have 10 web servers and you back up some of that, and you have a database server and you back up some of that, and you have your file server and you back up some of that, having somewhere to put all that is really handy. And then putting it off-site means if something happens to your primary data center, you always have a way to get your data back. For a while, we were actually running our stuff on 2 data centers in Chicago, which wasn't good enough for us. So we shut down one of them and moved the rest of our stuff to Texas. So now we have our data center in Chicago, our data center in Texas, and now you could blow Chicago up and we'd still be online. We're always available. That's what highly available means, right? And what we like to call this kind of situation in the next slide is, I guess you could call it disaster recovery. This is another scenario of how to organize your 4 servers. This one is kind of like, I guess if you don't want to have your replica there, you could put your replica there. But you always have 2 Postgres servers, no matter where you put them. And if you have a second data center, put it there. But why would you do this? Well, I don't know if you guys know this, but back in the mid to late 90s, there was a string of crazy internet outages, like main backbone outages, like freaking, not just Google went down, like Cisco and, Level 3 went down, and AT&T went down, and it was a crazy list of occurrences that like all these major backbones for the entire internet were just going offline. And it turns out that every single time this happened, it was a backhoe because they didn't call Aaron to get to like where the lines were, or they like dug a little too deep. And so all these crazy outages in like the mid to late 90s and the early 2000s were because of a backhoe that pulled up a fiber channel line or something. So that takes your data center offline. So having another data center somewhere else that's on some other internet connection to the world makes it so you can avoid those kind of situations. And natural disasters are always nice. This is a picture of Iowa. I think that was after the huge floods that hit it in 2008, but I actually lived there right after this happened. No, it wasn't. It was in the early 2000s. The late 90s. It was before I moved there, but this happened there. And when the hurricanes hit the East Coast, same situation. You lose all of your data centers that are local because they're immersed in fluids, and they don't like that very much. And then, of course, everyone loves Murphy's Law. Sometimes stuff just happens. Like, I don't know, your servers could catch fire, and that would take down your rack. Maybe someone broke into the place and stole someone else's server, so they lock it down so you can't get to it anymore. Maybe someone stole your server. If you ever go to a data center, what's crazy is sometimes they have like these security doors and stuff, and they like monitor you, and they have cameras everywhere, and they're so paranoid about espionage and stuff. Well, there's a lot of stuff that can go wrong. I'm not even going to list them all because you're imaginative people, right? You can come up with some kind of scenario where something blows up in your face. And well, isn't he cute though? It's kind of hard to hate him. The cute pile of poo. But really, it all boils down to Murphy's Law, and I'm saying the phrase boils down a lot. I don't know why I didn't when I was testing out this presentation. So what are we missing? What are we missing in our stack of 4 servers? Yeah, I don't know why I did that. So what's missing is that we're not running Postgres everywhere. We kind of were in that one slide back here where we had the 4, but we're really not, because what we have in this situation is if the Postgres still goes down in the primary data center, that immediately means we have to switch to our disaster recovery node, which some of the local web servers in your primary data center may not like that. They like to talk locally. And causing your entire company to switch over to the disaster recovery data center just because your database node went down, not a great solution. So what I generally see is we'll have a situation where you have 5 servers, 3 of which are Postgres. You have your binary pair, so if one goes down, you can switch to it immediately. And then if shit really hits the fan, you can go to your disaster recovery node and then be up for a while until you can restore your primary data center to operating capacity. This I consider, personally, the bare minimum of saying you claim you have a highly available structure. Your skeleton is mostly complete at this point. And again, this is where your expenses start to add up because you've got the separate data center, you've got 3 Postgres servers, all of which have the same hardware profile, hopefully. Although some people argue that the disaster recovery system doesn't have to be quite up to par because that's like if you're running on your disaster recovery system, you've got other problems probably right now. So you can reduce capacity a little bit, and people won't complain too much. So everything I summarize is on here. You should see my liner notes, they're crazy. But again, you're kind of splitting up everything so that you have some kind of alternative if something really goes wrong. And again, what is missing in our situation here? Is anything missing? Can anyone pipe up? Not to put you on the spot or anything, but.
I'm thinking web and application.
No. This is database related. We don't care about the web app right now. Like, the web apps can connect all they want. Like, we assume there's like 500 web application servers, because they don't care about the database servers. This is just us kind of looking out for ourselves. Right. Well, that's kind of cheating. I probably shouldn't have said that. But, so yeah, what's missing is our 6th server. Well, 4th server, really. But the question that you need to answer here is, how much do you depend on your disaster recovery system? Or how much do you think you might depend on your disaster recovery system? What I mean here is, say your first data center goes down, and you have to run off your secondary data center for like a week or a month or for some indeterminate amount of time. And once you're doing that, how likely is it for one of those nodes to fail? Well, I had that happen to me once. We had actually we had some problems with our main data center was actually having network issues, so we switched to the disaster recovery nodes. And then as soon as we fired up the main application, the primary node, that first node on the Postgres list, promptly fell over and died. It just so happens we didn't do a lot of load tests in our disaster recovery system. It had a bad piece of hardware in it, and we didn't know. So it was faithfully replicating all the Postgres stuff, the transaction logs we were sending over, but it wasn't able to handle much more than that. So it promptly fell over and died. So we were on the secondary Postgres node the second we had to switch over. So in that situation, we of course did what we could to fix the other node and then eventually flipped over the pairs. So we had 2 eventually. And we were in disaster recovery for like a week or 2. And because we're a financial institution and because we had a website that was online and because we were handling, 1.8 billion queries per day, ended up being like 300 million transactions per day, we couldn't be down for very much time at all. And our disaster recovery systems had to be able to handle that kind of load all by themselves. So in this situation, we had this kind of cluster because we pretty much had to. And again, I'm just going to reiterate why we would need to do this. If you can't afford having all of your systems be the same servers, what I'll generally see is what people will do is they'll take their 2 servers in the primary data center, and when they're upgraded, they'll take the old servers and put those in disaster recovery, right? Because those clearly could handle the load, just maybe not as well as the brand new servers you just installed. That's one way to kind of save some money. But again, if you really want to go for the whole hog and really commit to this, you're buying all your servers, to do some kind of cycle anyway. But again, really only companies that have way too much cash to know what to do with will do that. So we're done, right? We're done. Job done. We're finished. All was well that ends well. Who here thinks I'm lying? Everyone? Okay, so it's probably something in my voice, maybe, I don't know. So I'm lying because sometimes you can't account for everything. And the situation I'm about to describe is something you've probably seen. If you read XKCD, this is the comic that they kind of use to make fun of SQL injection attacks. This isn't what affected us, but the title of the slide kind of is a hint to what happened to us in particular. So the problem with synchronizing all of your data so that it's online all the time and highly available and always there for you, like if one server goes down, you got the second server. If the second server goes down, you got disaster recovery. If the disaster recovery node goes down, you got the second disaster recovery node. You're covered, right? Well, not all the time. this is the server structure that I personally recommend as your final end-all be-all if you have your own servers and you're not in the cloud somewhere. And even if you are in the cloud, having multiple zones and then also arranging them so that you can have some kind of similar structure to this is probably recommended. Because your failure scenarios are the same, they're just a different kind of layer. Instead of just servers, it's various cloud providers or zones and whatnot. So here's why I came up with this structure. Sorry, that's a little ahead of myself. Forgot about this next slide. So how do you implement something like this? Well, in 9.4, the best setting ever came out, recovery min apply delay. What that setting does is it tells the server you set it up on, usually a secondary server or some kind of standby system. Basically, you tell it, I want the server to always be behind by, I don't know, 2 hours. It's a good starting point, right? And why you apply that layer of kind of abstraction is so it gives you time. So if something percolates through the system, like some kind of corruption or a malicious attack or whatever, it doesn't get to all of your servers. You always have a clean room that kind of is a little bit behind. And if your monitoring environment or your checks or whatever else can find the issue before it kind of reaches that system, you can stop its replication with replay pause, and then you can use it to kind of replace the data on all the other servers that were ruined somehow. It's kind of like your, in case of emergency, break glass server. This used to be a lot harder to do before because if you're streaming replica, depending on streaming replication, any kind of problem immediately gets replicated everywhere. It's everywhere all instantly and you're kind of screwed. So your high availability stuff kind of shoots yourself in the foot. Well, with this, you don't quite have that problem. Before you kind of had to build a server like this and then depend on find and only using wall replay, and you had to set it up. It was just a convoluted mess. Now you just change one setting in the config file and you're done. So the other thing you can do is in 9.5, there's a new feature called archive mode equals always. Now you probably noticed if you have a streaming replica, if you have the archive mode on and you have the archive command set to some command, it doesn't actually execute that some command, right? And the reason they do that, obviously, is because you have your slaves. They don't need to produce their own archive logs because they're getting them from the master. It's the same data. Well, it took them a while to realize this, but you probably have also noticed that in the documentation they say archive command is some kind of value that is a command. It's just arbitrary. A lot of people use copy. Some people use rsync. There's tools out there that kind of can wrap it and make it a little more complete. But we had a very sobering conversation in PGCon this year in Canada that sometimes there's a lot of one-off cases. Like there's partially written files, there's files that didn't transfer completely with rsync, or maybe you had a network issue, and then you end up failing over and you don't know which archive ones are the right ones after your timelines have migrated. Well, to make it easy, just have all your servers write the archive logs where they are. So every server has local copies of the archive logs, so there's no more partial transmissions. There's no more, juggling which archive logs are, need to be sent to which machines. They're all everywhere. And if you have a cleanup script to make sure they don't pile up, that generally will save you from having, issues with trying to decide like what stream you should be using. This is a setting that I recommend eventually figuring out and kind of playing with. They talk more about it in the documentation, obviously, so I'm kind of glossing over it. And so notice the titles again. Have a backup plan and be paranoid, or do what happened to us. So this is the probably penultimate story that I've kind of run into in my experience 10 years using Postgres. So now, imagine a scenario. We have the full 6-server stack on the 2 data centers, and we've got everything, and we're bulletproof. We've got all this cool stuff. We're amazed. We're like, yes, this is awesome. We're staying up, and we had stayed up. Like we had like some 20 crazy continuous uptime of like 2 years or some ridiculous thing. So we're doing a hardware upgrade. We got new PCIe NVRAM cards that were like, yeah, these are awesome. We need to put these in now. And we were using DRBD to copy the data from one server to the other because it's binary level. Like Postgres doesn't even know what's happening. And so if the Postgres server crashed, we could bring the other one would just be up and it would have the same exact data. Like we didn't have to depend on Postgres replication at all. It was just there. And it's more up to date than even the Postgres replication. And the reason we had to do that is because, like I said, 1.8 billion queries per day is a little more than the Postgres replication can keep up with. Like, we wanted it like as immediately as it was written to disk, we got it. So unfortunately, TRBD had a bug that was we did not know about, that when you change the hardware underneath it, it also changes its metadata to accommodate the new size of the hardware. What we had done is we took the size of the existing hardware and made the new hardware the same allocated size with LVM. So they were the same. And then we were going to copy the data, and once the data was copied, we were going to expand it and then do the same thing to the other server and kind of reverse the process. That was how we were going to do the upgrade. And that was progressing wonderfully. It was doing it exactly the way it was supposed to. Our upgrade was proceeding as planned. And then the metadata on the secondary server, when we connected it back to the primary to copy everything over again, the primary said, hey, your metadata block size is different from mine. Let me take that. So the bug in VRBD was that the primary took a setting from the secondary and then used it. That should never, ever happen. If it didn't match, the primary should have said, you don't have my setting, go away. Instead, the primary changed its settings based on the secondary. That's a huge no-no in pretty much every scenario I've ever seen. So that was the bug that got us. So imagine.
Sorry, has it since been fixed, the bug?
Yeah, I know it's been fixed, but at the time, this was like 8.4.2. So at the time, this is what got us. So imagine your metadata is a little bit off, and the primary has all of your main data. So we had the database up, and we were in testing mode before you released it out to customers to make sure that the hardware upgrade worked properly. So for an hour, we were running our various tests, and then the QA guys were piping up. They're like, hey guys, these tests kind of look a little weird. Like the data doesn't quite look the way it should. Can you look into that? So we started looking into that. This was going on for an hour. And then we started to realize, oh no, this is data corruption, like from the disk level. And it had gotten into memory, and then it had gotten to the secondary server, and then it had propagated through our disaster recovery nodes, and everywhere. So our 1.2 terabytes of data that was in 4 different locations was ruined. The only thing we could do at that point was take a backup from the previous night, find all the transaction logs since then, and roll it forward very slowly. So our 1 hour upgrade suddenly became a 7-hour scramble to restore our 300 gig backup to some other location and then slowly propagate it back through our stack. That's why we have this server right here, the warm standby, because your paranoia will always pay off. But again, this is expensive. Having these extra servers that are sitting around kind of waiting to, for your just-in-case purposes, a lot of people see that as overhead. And it is in a lot of ways. But it can save you a lot of time. Like how much did 7 hours cost us of being down? Right? Because we're an online trading firm, we only really care about 8:30 to 3:30. Plus a little bit before and after that to make sure we're available for the market. Now, if you were a website, being down for 7 hours is a lot more of a big deal. And it can be a lot more problematic. So however you decide to build your stack can depend on how paranoid you are and how likely you are things can go wrong, or not even how likely, how much it would cost if it did. That's your foundation. That's the bones of what Postgres runs on. And Postgres is kind of like the skin that goes over it, because it depends on the foundation you build and how much you're willing to spend on it. And even the craziest, most over-engineered structure can not be enough sometimes, as we painfully found out. So one of the ways the other ways you can get around this is 9.2 they added data checksums. But unfortunately with data checksums, you have to reinitialize your database, which means a dump restore, because you can only do it during PG init. Actually, no, you could do it with PG upgrade, actually. Do a version-to-version upgrade, couldn't you? Nah, whatever. I'll let you guys hash that out. Maybe one of the major devs can mention something in another talk or tell me I'm wrong, because I probably am. But either way, data checksums are a way to fix this, because if we had data checksums enabled at the time, Postgres would have noticed the corruption a lot faster, and it wouldn't have been nearly as disastrous as it was for us. And just as another note, I like to mention PG Rewind because I'm so excited about it, because it makes it a lot easier to do the upgrade process I was talking about before. Failing off to your DR, that means you have to sync all the changes back to the master after you're done, and then kind of sync them back. And that's a lot easier now with 9.5, because it's basically rsync that understands write-ahead log structure and understands how Postgres works. So it only syncs the data files where they need to change. And suddenly you're switching from master to slave and back and forth. It's a lot easier, like by orders of magnitude, honestly. And that makes your paranoia a little less important, because it's you don't have to sit there and accidentally fat finger a command and erase something. Like, oh, I accidentally inverted the rsync source and target. Whoops. I've done that before. That's not fun. So here's all the various resources I kind of referred to in building this slide set. All the things I'd kind of mentioned in passing, like Picardo, Londas, Pacemaker, Rep Manager, etcd, AJ Proxy, that's all there. My slide set's going to be, I'm going to put it on the wiki after this is all said and done. It's not just going to be the slides. Like, you're going to see when I put it online, it's going to look like this. So like all my liner notes are in here, all the discussion, all my justifications for everything in here. That's what it looks like. It's just what it looks like online, the slide set. So if there's any questions or comments or tomatoes, you can insert those now, I suppose. I think I may have rushed this a little bit faster than I expected. Wow, no. 8 minutes left. Sweet. That's about what I wanted to do. Yeah?
How do you treat software upgrades and hard, so do you use that warm standby if you need to go back?
Okay, so the question was, how do I handle software upgrades? Generally, what I recommend for software upgrades, and this is probably similar to what we should have done in the first place with our upgrade process, is you decouple your disaster recovery system from your primary data center. You do the software upgrade there, make sure it's all tested and proper, and then when it's, when you're sure it's ready, since it's a software upgrade, you kind of have to wait to do disaster recovery anyway. What I would do at that point is I would do some kind of synchronization process like PG-based backup or rsync or whatever have you. Then you rebuild the DR from scratch, effectively. I mean, if you have like a 20 terabyte server, I wouldn't recommend doing that. I would say like, once the upgrade's finished on the primary, do like an rsync to kind of resync everything back up and get all your hint bits up to date, so it's not a full, sending all 20 terabytes over. But software upgrades are very similar. Hardware upgrades are just a little more invasive because they, you might have to erase the data and resync it over again like we did with our new drives. Anything else? All right.
Your opinions on like the different, like you had like one server being replicated to and stuff, right? But what if you had like flail or you had streams and cascading replication and stuff? What happens to that?
All right, so the question now is what I would do if I had like a chain of replicas or like cascades or multiple replicas. So I do admit this scenario was assuming you only had the one server that you just wanted to make sure it never ever went down. Well, one of the ways you can also do that is to have just a ton of replicas, right? And you can have all replicas at the same level, or you could chain them so you have like 20, 30 replicas, whatever. We actually have a couple of scenarios at where I work now. We have 150 instances, and I would say 140 of those are replicas or chains of replicas. In that particular case, you're not as, I guess, paranoid as if the slaves go down, but you still have to protect the master the same way. Unless you have like a BDR setup, and that's something that wasn't really an option until more recently. So the BDR for binary data replication, or if you have a multi-master or some kind of broadcasting system, that's something you can do. It's a little more of a new kind of, not quite as tested in the field kind of thing. And eventually maybe I'll update the slides and do it again somewhere else with that kind of situation in mind. But in this scenario, Ignore the slaves. They're like that second node. They're something you can fail over to if you need to. That primary is the one you're trying to protect. So it's the one you need to have like replicated 4 times in 20 data centers or whatever, because it's the one that really matters. You again?
How often do you test restore your backups?
How often do we test restore our backups? As often as you can do it without it being, I guess, a roadblock to getting other stuff done. Because your backups are only as good as how often, or as good as they can be restored and used. One of the ways we tested this is, in our particular setup, we took production data and from our backups, and we restored it in our stage and dev environments every day, because the devs wanted to have fresh copies of the recent production data so they could test with it or what have you. And that way we knew if the backup ever failed to restore, we would have 20 devs knocking on our door saying, we can't get to the restore data. And usually it was because something in my restore stack broke or some automated thing kind of fell over. But sometimes it was because the backup was kind of wonky somehow, or like there was a hint bit missing, or one of the C files was missing, or the C, the things that track the transactions. There's a PG like C log, the C logs. Like sometimes for some reason those were kind of getting backed up wrong or corrupted, or I don't know what was going on, but for a while there, before I could get it properly doing it, those files weren't properly representing the transactions that were there. So we'd have to create a 0-1 out. In the documentation, they tell you how to do this. You make a 0 length one, and then your restore will work. But it didn't matter because it was dev and stage. But it did mean that I had to go back into production and rerun the backup, so we had a real backup and then put that online. But I would say at least once a week. And then if you can afford it, or if you're, or in your case, or sorry, in our case, if your infrastructure depends on it, every day. Who else? Yeah, you.
So is there a parameter that we can set on the primary to protect the propagation of any corruption to the standby or any other high availability source?
Is there any kind of setting we can use to prevent corruption from getting to slaves? No, not really. I mean, I guess you can consider this the min apply delay. Like you can make it so the slaves aren't always live 100% of the time, but then you end up with, if your master goes down, your slaves are behind, you lose some of that data. But you have the transaction log, so you can roll it forward. But how many of your transactions are you willing to lose? Because if the master had not written any of those out yet, or if the transaction logs hadn't been transmitted yet, then you're kind of SOL. Although I suppose you could combine recovery min apply delay with archive mode, and then I'm not sure because I haven't tested this, even if it hasn't applied the transaction logs, does it write them out on the slaves? Because if it does, then that means even though it hasn't applied the transaction log information it received, it still writes them out. That means if the master goes down, you can still roll them forward on the slave if you need to. That would be a really good combination. So I might want to try that sometime to see if it works.
If any blocks are corrupted on the primary, when it tries to apply,
Yeah, it would, which is why you'd want to know when the corruption happened, and then stop the replication and stop the roll forward until it hit that point. Use your point in time recovery so that it avoids that.
no, my question is, so say for example, there's a block corrupted on the primary, and if it tries to apply on the standby or the high available servers on the secondary data center, is it not going to check whether before applying?
It does, but here's the thing. Sometimes, unless you have checksumming fully enabled, it takes a lot of what's in that file at face value. Like it basically says it needs to change this block to this binary level. Like it's changing Postgres at the page level. So if the contents of the page are wrong, not the headers, just like something in the actual contents of the page are wrong, it'll apply it, faithfully, and then you'll have corrupt data in your database, or on one of your indexes, or on whatever. Postgres doesn't really have a lot of, it has some internal checks, but it doesn't have all of them, right? Because it's got to have some kind of, ability to apply the transaction logs in some kind of, linear time. If we had one of the devs in here, they'd be able to tell you more about it. Yeah? What do you mean by a rolling upgrade?
9.3 master replicating to 9.5 or 9.4.
No, you can't do that.
So that's something that is very useful, right? When you have a 20 terabyte database all over and we want highly available systems.
Yeah, so what you would generally do in that case is, okay, so the question is rolling upgrades. How do you do that between versions? What I would do in most situations is I would actually upgrade one of the slaves. I would decouple it and upgrade one of the slaves, and then you fail over to it, and then you upgrade the master and then switch back to it, or not even switch back to it, upgrade one of the masters and make it a new slave, and then slowly percolate that through the system. So that way you're always online. You're just a little, maybe less online, because you got to have some downtime, right? You can't do 100% up, you can't do an upgrade 100% of the time and never go down. You're going to have some downtime. The idea is to be down less than necessary, or not necessary. Less than is more than necessary. Try to avoid downtime by doing your upgrade in phases. So what I would do is, like I said, upgrade one of the secondaries, turn off writing on the master, switch over to the system that's been upgraded, and then you're upgraded. You can cascade it through your system, however you want. But again, since you have theoretically one of these structures, running on one server for like a few minutes or a few hours is not a big deal, because eventually it's going to be on all of the other servers, and your stack will be faithfully replicated. But yeah, hard upgrades are an issue. They're the one time where you might be down a little bit, but there's no way right now with Postgres to do an upgrade without going down, unless you use log-based replication like Sloaney or Picardo or Londist, in which case it's a little more of a management headache because you've got to actually sit there and coordinate all the tables manually over, and then you've got to sit there and tell them all to upgrade, and you can do it that way. I haven't yet. Usually I do the full Postgres-only tool upgrades. I think I saw a hand over here.
I was just going to comment that it depends what replication you're using.
Yeah.
So if you're using string drive, you can't do it, but if you're using like a Sloaney, then you could go to the main version.
Yeah, because trigger-based replication and those kind of replications aren't dependent on the version. They're not dependent on the binary files or any kind of version of Postgres. They just copy over the statements and the data as it is. So you can do that between versions. So you might, as a test, set up another side cluster, use Sloaney to replicate it to that, and then kind of shift over a little bit. So that is an option. I probably have time for one more.
Well, not really a question, but after 9.5 with BDR, will be able to do.
Oh yeah, I forgot about BDR. And like I mentioned earlier, BDR is a new thing that a lot of people aren't really sure all the capabilities it has, and that's one of the things it can do, is it allows you to do binary replication, because all the new functionality added in 9.3, or sorry, in 9.4, the replication for the the logical level logs, the logical logs that they added in 9.4 make that possible. So that's something that's going to be more, you're going to be seeing that more and more now from now on. Help solve that issue. Okay, I think that's it. I thank you for attending, and hope you found it useful.